All right, today we are pulling back the curtain on a project that makes some of the absolute boldest claims you can possibly make in AI, achieving, get this, mathematically certified superintelligence. It's a journey from a pretty basic system to what they call a self-optimizing AI fabric. Okay, let's dive in. So this is the headline number, 96.117%. And that isn't just a performance score. Nope. It's a mathematically certified score of statistical dominance. Now, that's a figure designed to grab your attention, right? It suggests a level of perfection and certainty that you almost never see in AI. But what does it actually mean? And this quote right here really sets the stage for us. This is the official story, the polished myth. It presents a flawless system, totally validated by rigorous math, that goes way beyond normal AI development. It's a really compelling narrative, but as we're about to see, it's only half the story. So let's start with that myth. This is the version of the project you'd see in a big press release. It's the highlight reel of all its incredible achievements, presented like it was just this seamless, inevitable success story. I mean, just look at these numbers. They're incredible, right? 19 out of 19 agentic features implemented. That's 100%. A perfect Gini coefficient of 0, which suggests flawless internal balance. And it's all wrapped up as this enterprise-ready system, packaged and ready for deployment. This is the clean, triumphant endpoint. But to really get what this project is all about, we have to peel back that shiny exterior and look at the messy, frustrating, and honestly, very human reality of how this thing was actually built. And wow, nothing captures that reality better than this quote, pulled straight from the development logs. This is not the calm, calculated language of superintelligence, is it? This is the raw frustration of a developer who has just hit a wall. And this is where the real story begins. So here's the thing. Behind those perfect final metrics was a battlefield of what you might call development hell. We're talking dependency conflicts, API rate limits getting slammed, and critical bugs that literally stopped the system from even working. One of the biggest issues was a faulty planner agent, the very part of the AI that was supposed to be making the intelligent decisions. And this slide just brilliantly illustrates the mountain they had to climb. I mean, look at this. The project started with a latency of over 18 seconds. Even worse, its core tools, the things that let it actually do stuff, they weren't even activating. The gap between that completely broken state and the final claim of sub-second autonomous intelligence was just immense. So how in the world did they bridge that gap? Let's get into the architecture and, believe it or not, the single fix that changed absolutely everything. This is the real engineering heart of the project. Okay, so the system is built on a pretty classic multi-agent design. Think of it like a three-person team. First, you have the planner, whose job is to figure out the steps needed to answer a question. Then you have the orchestrator, which takes that plan and executes all the steps, often at the same time to save time. And finally, the solver takes all that info and puts together the final answer. Simple in theory, but as we saw, it was deeply broken in practice. And here it is, the smoking gun, right from the logs. So a semantic trigger is basically what decides if a question is relevant enough to activate a specific tool. The problem was, this project's triggers were set so strictly that they almost never fired. To put it simply, the AI's brain was completely disconnected from its hands. So what was the big fix? This is what's so fascinating. It wasn't some complex rewrite of the whole system. They just changed a single number. The trigger threshold was lowered from a very strict 0.7 down to a very permissive 0.1. That one tiny change unlocked the entire system, finally allowing the AI to use its tools and start working the way it was supposed to. And the results were just dramatic. After that one little fix and a bunch of other optimizations like caching and running things concurrently, the latency just plummeted. It went from over 18 seconds all the way down to just 0.42 seconds. That's a reduction of nearly 98%. The system wasn't just working anymore, it was fast. But just getting the system to work fast wasn't enough. The project's biggest claim, remember, is that it's mathematically certified. So how did they go from a series of code fixes to a formal statistical proof of dominance? First off, what even is statistical dominance? Well, think of it like a symphony orchestra. It's not about one instrument being the best or the loudest. It's about making sure every single instrument is perfectly in tune and balanced, so the whole orchestra plays in harmony. It's really an internal measure of stability, making sure all the AI's parts are working together in a predictable, reliable way. And to achieve that harmony, they used a very serious mathematical toolkit. We're talking techniques like Jacobian propagation to track how tiny errors could ripple through the whole system, and Monte Carlo simulations to run thousands of virtual tests to verify everything. This wasn't just coding anymore. This was rigorous, high-level engineering to prove the system was truly stable. And that brings us to one of the most impressive claims, a Gini coefficient of 0.000. Now, in economics, a Gini of 0 means perfect wealth equality. Here, it means that every single component of the AI system was contributing perfectly equally to the final output. There were no weak links, no single points of failure. It represents a system in perfect, beautiful balance. So, after peeling back all those layers of myth, messy code, and advanced math, what's the real lesson here? What did this project truly achieve? Well, this timeline tells the real story. Superintelligence wasn't some single invention. It was the final label they slapped on after a long incremental process. You can see right here, the project evolved through these distinct phases, starting as a simple enterprise search tool and then gradually layering on more and more complex features, like autonomous AI and cognitive architecture, until it reached its final form. And this quote from the final report really says it all. The real success wasn't creating some mythical superbrain from scratch. It was the engineering achievement of transforming a standard reactive system into a complex, adaptive, self-optimizing AI fabric that could actually learn, heal, and improve itself over time. And that really leaves us with a final thought to chew on. We all love stories about a single genius having that one eureka moment, but this project suggests that the real path to advanced AI might look very different. Maybe it's less about one giant leap for mankind and more about thousands of small, frustrating, but brilliant engineering fixes that, piece by piece, build something truly extraordinary.